Hi everyone. Yeah, been asked by quite a few tubers what I recommend and what I use to charge a flat 12-volt car battery. So I got one of these things. They're widely sold, anything between 15 and 25 quid. 12 volt 8 amp, 24 volt 4 amp. So it's a 12 and 24 volt battery rather than a 6 and a 12. Well, you probably don't need 24, so it's got an extra function which you don't need again, because most people have just got 12 volt batteries, let's face it. But they're trying to address the whole market with one product. And it's a smart 3-stage battery charger, it says. And I don't have the instructions with it because I've lost them. So I'll just work out what it does, but just give it a quick test to see how it performs. This is the actual device here. Oh, something there. This is the actual device. You can see I've had it for about 6 or 7 months, I think. And mode selection, vehicle mode, and you just hit this thing and it scrolls through the modes. I'll show you in a minute. And there's also a pulsing repair mode, which we'll just see what that does for us as well. Intelligent detection, so it's going to check whether it's 12 or 24. We're only interested in 12 volt. Winter and summer settings. It has got a thermocouple or a thermistor inside and a fan, so it's got a fan, so it's not IP 50 or 60. Actually, there's no IP rating on this basically, because it's not splash proof and it's not waterproof and it's not dust proof. Right, so I'll just zoom in on this so you can have a quick look. Right, okay, right, so yeah, it comes with this plug and a death adapter, as Big Clive calls them. Not sure what I've done with it. Yeah, I'll find the death adapter. I'll show you what it came with. In a minute, I'm just going to cut this off, this plug, and put a 13 amp one on, because it's been annoying me anyway. Yeah, I'm just taking the 2-pin plug off. The cable's not bad actually. It's got a reasonable amount of what looks like copper. It's not aluminium. There's a rating on the cable. 2 times 0.5 millimeters squared. Tianchang, Shenzhen, China. So whether it's not really any sort of approvals. It's got CCC approval on there, look, which is a Chinese approval. It's not UL approved, and it's got no EN standard on it, so it's a piece of Chinese cable basically. Chinese mains cable, and it says 200 volts, 300V, 300V, so presumably it's okay for what we want. EC5221. No, I don't know what it is. It's a marking standard, I think. Anyway, whatever it is, I don't know. Anyway, look, it's got reasonable copper in it. I'll stick this plug and I'll come back to you. Okay, she's connected to the mains. We plugged her in. Mode selector, look, we're off at the moment because there's nothing connected. We've just got very short leads on the battery clamps. Surprisingly thin cable, actually. A reasonable spring, not great quality, but yeah, they're strong enough, I guess, for 8 amps. Haven't gone rusty. It's been out in the garage for some time. Oh, hello, this comes off, look. So yeah, you can see it's just already tin plated mild steel, I think, and it's nice to see the battery cable, or the actual charge cable, has been soldered on, but they haven't even bothered to do up the strain relief on it. Look, so let's give that a bit of a tweak just to give it a bit more strain relief on the actual cable itself. Everything's too cheap in it from China. Wouldn't you rather pay a bit more and have something that lasts a lot longer? Answers on a postcard. Will this one come off? Yes, it will. And that one's not been strain relieved either, so let's just do that now. Just give it a little bit more robustivity, whatever the word is. Come on, baby, you can do it. Take it all. Yeah. Well, the plating's coming off, look. You see, as you fold the metal, the actual tin plating is coming off. You see that? Can you see that? It's not very encouraging, is it? But anyway, look, it's been used, this battery charger, and it's alright. There we are. So that's a final assembly done by half battery. Right, so if we just, this is the mode selector, look. So it'll go off, pulse mode, pulse repair. So I think that's the only mode that will work when there's no battery connected, because it might be trying to recover a dead flat battery, and that's turned itself off again. So it's intelligent. It knows what I'm thinking. I'm thinking we should connect it up to a test load and see what we get. So I just rig it up and just see what it does, and then we'll take it apart and have a look inside. That's the interesting bit. Made in China. 2019 11 look. So yeah, it's a year, getting on for a year old since it left the factory. So it hasn't had time for the capacitor to dry out. They're due to dry out middle of next year. Right, so what should we do? Let's connect her up. If you want to see the volts, and then okay, I'll wire it all up and I'll come back to you. Just a quick test. Huh. Never seen this before. I'll just show you what's happening. Right, I've got the units on the bench under test. Got the camera up there. Got an HDMI cable running past the power meter up here. It just runs around about 8 inches away, and then up onto the monitor, so I can see what I'm filming up there. That's the monitor on the wall. Watch what happens when I turn the load on and the thing starts to output power to the battery. Watch this. So this is just the DC load going on to provide the 8 amps battery load. It kills my monitor. Clearly this thing is radiating like crazy in these battery leads. Turn the power off again. This is nothing, there's no connection to the monitor or the circuit of the camera, and watch what happens when I turn the power off. It stops conducting. There it comes back. So yeah, we've got a serious EMC issue with this charger, which I never realised. We'll get the spectrum analyzer out in a minute and see what's coming out of it, shall we? So, not good. I'm going to think of an alternative method for this. Well, I've tried twisting all the leads together on the test rig and moving the cables around, and it just won't stop the monitor from failing. So I'm just going to do this without a monitor. So we've got an EMC emissions issue with this. It's not CE approved. Is there a CE mark on the back? Yeah, it's got FCC and CE marks. China export mark, that is. Clearly not a compliant product. We'll stick the spectrum analyzer on it and we'll just see what's coming out, shall we, in a bit. That should be interesting. Alright, it's running, but my screen is still dying when I draw some power out of it. Clearly it's an evil EMC emitter. We'll find out what it is. Right, so where are we at? Okay, so the constant voltage load box, which is an electronic piece of test equipment, is connected. We're set to 13.9 volts. Actually, no, we're set to 12.5 volts constant voltage load. So this thing will maintain the, when I turn the load on, it will maintain the terminal voltage of 12.5. Okay, the meter, this meter is reading the voltage, and it's connected directly across the battery charger terminal, so that's accurate. And this is in series with the battery charger electronics, so this is reading your current down here. So if I just turn the load on now, constant voltage of 12.5 volts, and oh, that's a MIG error, isn't it? What's going on there? Look, 7.8 amps, which is fine. 14.1. We've got 13.73 on the terminals. So the voltage is, yeah, I mean that's connected directly to the terminal itself. Let's just try putting it on there and see if it makes any difference. 13.7. No, it makes no difference at all. Alright, so you got, I can't even see what it says because it's blanking my bloody screen. Put thing there so I can actually see it. I can't see it otherwise. It's one of those displays which is not very bright. Right, can you see that? You can. Right, good. Okay, so where are we at? Yeah, so yeah, I've been using this and it's done some strange things actually. If I just knock down to 6 volt, a 6 volt load, so basically a car battery that's run right down to 6 volts and go enter, I get 9 amps. So it will start to really pump some power into your battery when the battery is low to get you back up. It won't necessarily do the battery life any good, but if you want to go to work, that's what you need. You need some power in there. So recovery mode from a flat battery, a very flat battery. So 6 volts gives us 9.16 amps. Now if I just... Alright, let's give it a straight run. Let's give it one straight run. We're going in with a completely flat battery. So I've got a 10.5 volt battery, discharge at 10.5, turn the power on, and we get immediately a charge of 12 volts, 11.76 is the actual voltage down here, and 8 amps. So we've got 8 amps, okay. So this thing will get you going. It'll start stuffing the charge straight back in the battery. None of this sort of, are you a 6 volt, are you a 12 volt, I'm going to mess about for ages and then start pulsing you. This thing just starts pouring the power in. So from a point of view of a get you going battery charger, it's quite good. But is it any good at a maintenance battery charger? Let's find out. So you note down here we've got 11.7 across the battery crock clips. Actually on the charger, not on the terminals of the battery. That's actually the voltage across, they're clipped onto the actual crocodile clips themselves, the body of the croc clip. And you can see we've got 11.7 and we've got 12 up here. Come on, 12. Yeah, so we've got 0.25 error at this point, and we're pumping out amps. So I'm going to wind up the battery terminal voltage, up and up, and we'll see when the transitions happen, okay? Now, we're looking for a change in the actual charge current because it's supposed to be a 3-stage charger, so it will go into 3 stages hopefully. Now the Lidl and the Audi battery chargers have a distinct step function, and the CTEC, so it's just crept up slightly. So yeah, the voltage reading is still wrong, so we're waiting for this one to decrease. So I'm winding, and it's starting to drop. Okay, do you see it start to drop then? It's gone to 6.9 amps. 14 volts on the actual terminals, indicated 14.3. That would normally happen at 14.4 on most battery chargers. So yeah, it's happening low. It's interesting, isn't it? It's indicating the right thing there, but the actual is wrong. So there's just a basic, straightforward 0.3 volt error we've got at the moment on the 0.2 volt error on the battery terminal voltage. Unclear about the temperature compensation. Clearly if this compensation is working properly, then this might be a better thing. I'm going to look at a chart in a moment and we'll see. Okay, so if I just carry on winding up until this continues to drop. Look, it's just ramping down. 14.2, ramping down, so it's a slope. It reduces with the battery voltage. So let's go to 14.4 on the indicator down here. That's the actual battery terminal voltage. 14. Hello. I see it. It's dropping the current, which is the resistance in the leads is not compensated for. So as it drops the current, the voltage starts to creep up on the terminals. Do you see that? So that's a strange thing. So we've got 14.6 and we've still got 14.3 there. So we've still got a 0.3 volt error on the actual battery voltage, terminal voltage. And we're actually at 14. Let's run up to 14.4, and then it's turned off. So it shuts off at 14.4, which is too low really for a 12 volt lead acid battery. Should be about 15 volts. There's no trickle charge. It goes down to about 1.5 amps and just carries on charging. So it's quite a brutal charger, but it'll do it quickly for you. It's not a long, refined charging process. It's a quick and dirty, will get you going, and because it's shutting off too early, it won't fully charge your battery. I'm going to check the actual temperature compensation charts on the Yaesu website in a minute and see. So interesting enough, so it's completely shut off. There's no current flowing at all. Let's just wind the battery voltage back down, and you can see, look, the amp is just coming back up and up as we go down. You're going back to the full 8 amps. You know, so it's sort of a leisure battery. It will recharge. It will, if you turn, you know, caravan, leave the light on like we were talking about on last video. It will recharge. The only thing you've got to watch out for this, it doesn't really have any finesse. It's a bit of a blunt tool really for battery maintenance. But get you out of trouble, but not completely charge your battery. That's fine, okay. Now, how hot's it getting? It's not surprising that it's staying quite cool because it's got a fan in it, isn't it? So, yeah, I mean, that's a very quick review of this battery charger. I'm going to take it apart in a minute and have a look inside. So the only thing other thing we need to look at is what this pulse mode is all about, don't we? Yes, we do. So where's my lead? my DC load has got a 10 volt, a 0 to 10 volt output cable on it, which can feed into the scope, and we can get a direct live reading of the current on the scope. So when this thing goes into pulse mode, we'll be able to see what it's doing. Now, as usual, I've lost the cable. I'll have to find the cable and come back to you, I think. Yeah, so there's the current waveform. You can see all the noise. That should be a nice square wave, a nice straight line, as it would be on the other chargers. But you're getting a peak of 8 amps, 500 milliseconds on, 500 milliseconds off, or 350 milliseconds. So it's 500 milliseconds on, 300 milliseconds off to recondition your battery. And to be fair, it probably would recondition. It would strip off the if it's a mild case of sulfation, it would probably help. Okay, so don't leave it connected for too long, because it's not that smart. Right, so that's the waveform. Horrible noise impressed on the output. We'll open it up and see why that's the case. Okay, so we'll do that now. Alright, so let's take this apart and have a look inside, shall we? Let's get this cover off. Alright, so take these boots off. The boots, and find a screwdriver. If we can find one somewhere. Yep, there we are. It's unplugged at the moment. Whip these 4 screws out. Let's have a look inside and what this horrific filtering circuit is. So this is definitely not CE approved. It's way too noisy. Haven't taken any consideration of filtering. Shouldn't be on sale on the UK, really. You saw it interfering with my monitor. It will interfere with all sorts. We'll have a look on the spectrum analyzer in a minute and just see just how bad it is. But it's bad. No CE testing done on this, I can tell you that now. Shouldn't be in the EU at all. It is an illegal product. But that never bothered the Chinese. Okay. Right, so there's the fan. Let's see what we've got. Powered down. No, we're not. Powered down now, we are. Actually, it was unplugged, so we're okay. So let's just pull this plug out here. Okay, so plug for the fan, plug for the display. Display's mounted in there, as you can see. Seems to work okay. So what have we got? Yes, look, absolutely. If you look at the Auto XS and the little battery charger, you'll find that there is an input filter. They've shorted out the actual common mode mains filter, and there is no position for a common mode or any sort of inductive filter on the output. You've just got your transformer, your output rectifier diode, and I'm not sure, DH60N06. So that's just a FET to switch the output on and off, presumably. That's just a normal FET. So yeah, very crude design, really. Lots of components missing. There's just no filtering on the output or the input. Not CE approved, as I said. They've got a standard fuse, which is nice. Got another one of these tinky winky little varistors to try and soak up the transients from the mains, stop them damaging the switching transistor on the power supply, and also the input capacitor. 100 microfarad 400 volt capacitor. Make is XED, which is some crappy Chinese make, presumably. Cheap as chips. Got reasonable isolation between the high voltage side and the consumer side, so presumably, providing the insulation of this transformer is okay, then it's probably relatively safe to use. And there's the current shunt there. That's a piece of resisted wire which all the current goes through, and you just measure the voltage across that to actually feed back the current back to the microprocessor, direct reading. And you've got your standard power supply on the back, alright? But nicely made, well soldered, I'd say. It looks like it's been manufactured to a reasonable standard. I mean, look at the standard of the soldering on there and the layout of the board. It looks alright, doesn't it? yeah, but minimalist design with no consideration for emissions, you know, electromagnetic emissions. So very noisy, very crude, and not that accurate on the voltage. But if you want a charger to plug in to get you going, to pump some charge into your battery and probably do a decent reconditioning job, providing you monitor it and don't do it for too long. I don't have the instruction manual for this at the moment, so I can't really reference the instructions to see whether it actually does what it says it does on the tin, if you like. But yeah, crude. I've never seen a switch mode power supply without an input filter on it of this kind of power, 8 amps, a 96 watt charger, 100 watt charger. So yeah, crude, very crude, but probably effective when you're just charging a battery, I guess, your car battery. I'm not going to bother testing on 24 volts because most people are going to buy this for a 12 volt car, aren't they? And yeah, I mean, you get what you pay for. These are about between 13 or 14 pounds on Banggood, up to about 20-25 quid on eBay. This thing, very common. It comes in different colours. They've done a yellow one as well as an orange one, but it's the same inside. So yeah, minimalist and well made, but badly designed. It should have some filters here, which they've just bridged out a input filter, and the input filter capacitor is completely missing. Look, that should be a class Y filter capacitor to filter out the switching noise from this. So it's just really noisy, Let's switch over to the spectrum analyzer and see what we get. So we've got the spectrum analyzer. I've got a piece of cable dangling in the front, obviously a short, 0.5 metre piece of just wire hanging out the front. It isn't going to be a calibrated coupling, and also it won't couple as well at lower frequencies. As it gets into the tune of the antenna, the coupling to the source will get much greater. But anyway, what have we got here? We've got centre frequency of 500 kilohertz, and the span. How can the centre frequency be 500 kilohertz and the span 500? So frequency, centre frequency 250 kilohertz, right? So we're now at 250 kilohertz centre, and we're up to 500 kilohertz on the screen. So we're scanning the first half megahertz, and if I just put the peak, what are we going to do? Just trace up my other analyzers in a rack, but I can't move it. Trace max hold. There you go. So we're integrating now. We're holding the maximum values, and you can see there is some other switch mode power supplies around here somewhere. There's a switch mode power supply in the scope. There's the PC. There's some other noise coming up. But if I just turn the load on to this, actually that is probably. If I just turn the battery charger off completely, and then do clear right, and then max hold. Yeah, so all of that is coming from that power supply. And of course, because there's no filters on the input or the output, it will be radiating down the cables as well. So the cables themselves and the house wiring will be working as quite an effective antenna, really. So if I turn the power back on, we can see what it's like when it's just idling. There's no battery load connected. You can see these peaks starting to appear here. But as soon as we start driving some current, this is the full 7.9 amps, you can see these nasty peaks rising up, and all these down here are all radiating from the power supply, possibly from the cables actually, because there's no filtration. So this is I think this is the least CE product I've ever seen from China. This is a serious source of interference, this thing. So if we go down here, I'm just going to move the marker. I'll leave that there actually. There, we're back to the thing, and if I go to the marker, you can see this little tinky marker down here, this thing here. Can you see that moving along? We've got a peak at 100. The fundamentals down here somewhere 50. Then we've got 100. So the actual power supply is running at 50 kilohertz, right? And you've got odd and even harmonics, 151. You can see the 200, 250. You can see them going up. Okay, so that's the stuff radiating out the cables, but not necessarily in the sort of bandwidth. It would obviously interfere with long wave radio and stuff like that, but not do too much with with RF devices. For example, my HDMI signal, and my Bluetooth mouse is not working either. So when I turn this on, my Bluetooth mouse stops on my computer. In fact, it crashed the actual USB hub that's been stable for years. The whole hub crashed, and I had to power down the PC, turn the hub off, and power cycle the hub to get it working. Right, so let's go to a 2 megahertz span. Let's see what's a bit further up on the spectrum. So we'll go to 2 megahertz, and there you can see them all. Look at all those peaks. You can see every 50 kilohertz. Amplitude, trace, clear right, so that's just scanning. Okay, I go max hold again. You can see them all building up. So there's all the harmonics from this power supply. You wouldn't normally see that. What they would do on a EMC test would be take a certain bandwidth and then check the energy that's been radiated by the product in that energy band. Turn the power on again. You can see there they come back. As soon as you've got the thing conducting some current, there's a lot more current flowing, you get this radiation. So that's up to 2 megahertz. Let's try 5 megahertz span. 5 megahertz. Now that's been smoothed out probably by the resolution bandwidth, I'm not sure. You see down here we've got resolution bandwidth of 30 kilohertz, which will average out all those peaks. So if we change the resolution bandwidth to say 5 kilohertz, there you are. You can see instead of averaging it out now, we've got all the actual peaks. So we've got a horrible load of old mush coming on up to 3 megahertz or 2.5 megahertz. So let's try 5 megahertz. Hold on, frequency, stop frequency. That's around 5 megahertz already, aren't we? Of course we are, yeah. So you can see all the peaks there. So let's go up to 20 megahertz. Let's just be done with it. 20 megahertz. And we've got a resolution bandwidth of 3 kilohertz. And you can see that's all the... wait, if I turn this off completely and turn that off there, and then we'll just clear it. So trace... You can see. It's bloody dreadful, isn't it? Isn't that dreadful? If we go max hold now, turn the power onto the battery charger. That's that. And then turn the load onto the battery charger. That. Yeah. So we're going all the way up to 20 megahertz. 20 megahertz and beyond, which is it's a pretty good achievement to get a product like this to radiate in those wavelengths, because you know this is a 50 kilohertz power supply, for Christ's sake. But you know there's all sorts of ringing and horrible edges and fast edges which just aren't being filtered out. They're just going straight down the mains. Let's just try bigger ones to see if there's any really nasty spikes up on the what we're on at the moment. We're on 20 megahertz. Let's try 40 megahertz frequency. Stop frequency 50 megahertz. Right, so we'll go trace, clear right, max hold. Yeah, we're getting down to the minus 70 dB, and then the load is on at the moment. Okay, so let's just turn the whole thing off. Clear right. So that's the ambient in my office. What we got? We've got a peak around here somewhere. Got a slight peak around 15 megahertz or so. But you can see that, can't you? I mean, it's pretty flat. And then if I turn the battery charger back on, and even up to 50 megahertz, there's something coming up. So let's try 100 megahertz frequency. Stop frequency 100. Yeah, well, there you go. So not a CE approved, no filtration, not even a nod to CE or anything like that on this battery charger. So I'm gonna, in the next video, I'm gonna do a modification to it to get this running properly and not interfering with everything. Anyway, I just thought I'd put this in context for you so you can see a comparison. At the moment we are running a an Audi XS, we'll put it on car mode, 3.8 amps. Same location, same wiring, basically, running alongside the wires from the 9 amp one we've been looking at. So you can see that's the trace, okay? We're going up to 2 megahertz there, we've got a resolution bandwidth of 3 kilohertz. And there's not much going on. If I just clear right, you can see it all settled down, and that's what we call the noise floor. Right, so if I put max hold on now, alright, so that's the noise floor. There's quite a good signal at 987 kilohertz that keeps coming up from obviously a local transmitter or something, or a satellite link, or not a satellite, microwave link. Yeah, anyway, so that's that. So now if I just hit the switch and turn on the Rogue battery charger, watch this, and that's what that's chucking out. I'll turn off the little one now. The little one's disconnected now, clear right, and you can see it's a complete absolute EMC dog's dinner. Terrible thing, will interfere with lots of things. This is going up to 2 megahertz. If I put the frequency up to 5 megahertz, send frequency, stop frequency 5 megahertz. Look, Jesus, 10, 20, yep, it's still pumping out energy. I mean, compared to, you can see what the Audi XS, Auto XS battery charger from Audi was doing. Look at that. Don't know where to start. I mean, that's just a completely bad. Just wonder how far it goes up. Let's go up to 10 megahertz. There you go. And that's all the harmonics and transmissions from that power supply. So truly awful. Truly awful. Alright, so that's the comparison for you. We'll go back to the main video. So I hope you found that interesting. If you want to see more videos, then have a look down in this corner, down there, and hit the subscribe button and the notification bell, and leave me a like if you like. And yeah, so yeah, in short, in summary, a good battery charger for getting out of trouble, but don't use it if you've got a pacemaker or indoors, and don't use it to maintain your battery because the voltage is not accurate enough and it's a blunt instrument. Alright, so anyway, signing off now.